The gut and the microbiome is such an interesting area of research right now, and the amount of literature growing in the space continues to grow so much every single day. I'm sure by now you've heard of the potential benefits of making sure your gut is healthy, whether it's the gut-brain axis, the gut-hormone axis, the gut-bone axis, some sort of axis. The gut seems to be implicated in all aspects of our health. So it's really important that we make sure our gut and our microbiome is really healthy. So today we're going to look at a paper that looks at how the gut and the microbiome specifically may be implicated in health and longevity. Let's go. What's up, guys? My name is Richard and this is my channel Evolved Health, where my aim is to educate people on how they can improve their health, performance, and longevity. If you're new to the channel, make sure you hit the subscribe and the like button down below, and don't forget to hit the notification bell so you don't miss out on any of the new content. Alright, so today we're going to be looking at a recent paper, as I mentioned, called The Gut Microbiome Patterns Reflects Healthy Aging and Predicts Survival in Humans. You can see lots of authors on this one, and this was from, I think, July 2021, so it's a relatively recent paper. Now, you might be aware of some of the importance of gut health, but maybe not in relation to longevity and health span. And it is a growing area. There's been lots of research in animal studies and in mice models, but obviously we need to translate that more into humans. So that's what this paper looked to do, and there's been a lot of heterogeneity between the research. So they got a really big cohort to try to get good data on this and figure out what exactly is important when we're talking about the microbiome in relation to health, mortality, and longevity. So let's just start with the intro here. So again, they're looking at, they state that in older populations, studies over the past few years, as I mentioned, they've revealed a number of associations between the gut microbiome composition and measures of physical fitness, frailty, diet, all highlighting the importance of proper gut microbiome function into later decades of human life. But we've got to figure out what exactly that means. They talk a little bit about how a lot of the research is a bit mixed, but we talk about here, recent paper demonstrated that gut microbiome of centenarians under the 104 mark and supercentenarians over 104 show a depletion in core abundant taxa, Bacteroides, Roseburia, Faecobacterium, among others, complemented by an increase in the prevalence of rare taxa. And we're going to look into each of these in more detail. Here they state that some studies have also reported higher levels of gut alpha diversity. So that's the amount of difference within a population or within a sample. So if we're looking at the gut, it's the diversity within that gut. And in general, higher diversity seems to be better. And we see that here. So alpha diversity in centenarians compared with younger individuals, indicating that the gut microbiomes continue to develop within their hosts, even in later decades of human life. Here again, the loss of core taxa, the exact identities of which may vary across different human populations, for example, Bacteroides versus Prevotella, and the increase in alpha diversity reported in long-lived individuals suggests again that the gut microbiomes may become increasingly divergent or unique to each individual as they age. So in general, what we see in the research is very early in life, from when we're born to when we become children, there's a big shift in the microbiome, and then it's pretty stable through adulthood. But what they're saying is there seems to be this continual shift in the microbiome when we get older. So 50, 60 plus, we start to see this shift towards a more unique microbiome for that specific individual. And again, they talk about measures of alpha diversity have also been shown to be negatively correlated with frailty. So the lower the alpha diversity, so the lower the overall diversity in the microbiome, the increased risk of frailty and potentially other diseases, which has been shown in other studies. So obviously something's important with the gut, and we've got to figure out what exactly it is. And here, so again, they're just reiterating, although recent analyses have demonstrated a link between the gut microbiome composition and long-term health outcomes, the scarcity of cohorts with longitudinal follow-up data and the lack of detailed molecular phenotyping and health metrics and the relatively small sample size existing in studies limits the understanding. So the recent literature, or the literature up to date, has been quite mixed. The strength has been great, and they haven't looked at a lot of other factors in relation to health. So this study is trying to fill in the gaps in the research by looking at a few different cohorts. And here they looked at three main ones. So they have the Aravale cohort, osteoporotic fractures, or MROS, and they had an AGP one as well. So they're actually getting quite a large cohort, which makes the strength of the study really good. Looking at their Aravale ones first, So in support of what we said at the beginning, they showed that there was an initial drift towards an increasingly unique gut microbiome composition between the age of 40 and 50 at the genus level, and then continues on even into 50 and 60. So we start to see this shift towards a more unique one. And you can see a little bit here that general shift. So we see a shift more towards a unique with age over time. And it's the same in the other cohorts. And even when they look at all sorts of other sort of self-reported measures, lifestyle, health, etc., they said that age seemed to be the strongest association with the gut microbiome uniqueness. So this is particularly just due to age, which it's always tricky saying that it's just that, because there are other potential healthy habits that change, or lack thereof of healthy habits that change with age. So we can't say definitively if it's causation or correlation, but it seems that as we get older, there's this shift towards uniqueness, especially in healthy individuals. And that comes along with some metabolic changes. So in this study, they actually did some metabolomics. And what they found was there was actually a healthier metabolic shift, specifically with lipid profiles, in those with a more unique gut microbiome. And they're going to talk about what specifically happened with the metabolomics there. Oh yeah, just here. So they found, again, a few unique metabolites, all due to the microbiome, so microbial in origin, and they were mostly in relation to phenylalanine and tyrosine. Those were a few in that regard, which have been shown to potentially be inflammatory or xenobiotic sort of approach. And then they also found some both in the tryptophan pathway as well. So there seems to be some shift in the metabolomics from the microbiome that is imbuing potentially this protective mechanism. Now, whether, again, it's the people that are healthier tend to have a healthier microbiome, or if it's the microbiome that makes them healthier, it's hard to say from this, and I think we need further research that dives into it. Going back to the other cohort that they looked at, one thing they pointed out was actually quite interesting. With this sort of shift to uniqueness, there's a loss of the main taxa, so things like your Bacteroides, Prevotella, but there seems to be actually an increase in both beneficial and potentially pathogenic species that have been implicated in human longevity. So that's really interesting. Even these Methanobrevibacter, methanogens in general, a lot of people might know them due to SIBO and think that there's potential downsides there, but it looks like that even some of these species may be protective and enhance longevity. So the more uniqueness we have, the better. And again, showing that here participants were considerably more health heterogeneous at the time of sampling within the MRS. So when they looked at this a little bit different, they tend to already have chronic conditions, but even still they found associations within the microbiome. So they still observed a strong positive association between age and the genus level microbiome uniqueness. So multiple cohorts here showing that we're seeing this change in microbiome shift towards a more unique one and then generally healthier populations across multiple cohorts. When they look at mortality, especially in older aging, it gets really interesting. Obviously, this is something that should be quite important for all of us, of trying to make sure we live a long, healthy life. And coming back to the primary taxa again, they found that only the genus Bacteroides demonstrated a significant negative association with age after multiple hypotheses correction. So the loss of the Bacteroides seemed to be beneficial. If you maintain that, it was associated with higher mortality. And it is consistent with their gut dissimilarity analyses, where the uniting feature of unique microbiomes is, again, the depletion of the most common and dominant genera. Often Bacteroides, Prevotella, those are your big ones. However, in contrast, individuals in worse health demonstrated a distinct microbiome aging pattern characterized by a decline in a few other genuses. I'm not going to try to say these ones. So there seems to be, some specific shifts person to person and maybe in association with specific disease patterns, etc. But in general, we can find that there is a significant positive association between relative Bacteroides abundance and increased risk of all-cause mortality, independent of age, BMI, clinical site, self-perceived health, diagnosis of congestive heart failure, and in batch of stool samples. So again, that loss of the primary taxa Bacteroides seems to be a really important one. So it's something that maybe you can track over time, and we'll see how that shifts. Of course, research needs to be replicated. We need more data, but there seems to be an important aspect of that loss of Bacteroides. And even in replicating it in older individuals, still had a stronger association and higher hazard ratios. So again, pretty well correlated with that potential risk. And conversely, we saw mortality risk decreased in individuals with more unique gut microbiomes independent of the same covariates. So we want more uniqueness, less of the primary taxa like Bacteroides. And in the discussion, they summarize it really well here of what we want to take away from this. So number one, individual gut microbiomes became increasingly more unique to each individual with age, starting to the mid to late adulthood, and uniqueness was positively associated with known microbial metabolic markers implicated in immune regulation, inflammation, aging, and longevity. So that was the phenylalanine, tyrosine, tryptophan that we talked about. Number two, in the later decades of human lifespan, healthy individuals continue to show an increasingly unique gut microbial composition state, associated with a decline in the core taxa, specifically the Bacteroides, with age, whereas the pattern is absent in those with worse health. And three, individuals approaching extreme age, 85 plus, retention of high relative Bacteroides, abundance with a low gut microbiome uniqueness were both associated with significantly decreased survival in the course of the 4-year follow-up. So, to summarize that, we want high uniqueness as we age, and that can be both commensal bacteria and potentially pathogenic, which is interesting, but we definitely want this sort of lowering of the core taxa, specifically Bacteroides. Now, a lot of it seems to come down to the metabolomics that's in the gut, right? So those microbial metabolites seem to be what may be imbuing some of these benefits or having the actual effect. Unfortunately, not all of us can go get metabolomics done. That's not readily available yet outside of the lab, but we can sort of get a gauge, at least looking at our microbiome generally and specifically that alpha diversity to see where we sit. But if we can sort of start to look at some of these metabolites in the gut, we're going to start to get a much better picture potentially of where our health is. And when they talk about this in more detail, one of the main metabolites is the indoles. So there's various indoles, again, off that tryptophan metabolite, which seem to have many benefits. And this has been shown in other literature, which they talk about here. So they talk about bacterial indole metabolism is emerging as an important mediator of the gut microbiome post-immune homeostasis. So it helps regulate that immune system, which we know inflammaging and immunosenescence, that's all going to be a major player in longevity and healthy aging. One of the most recognized mechanisms of action of indole metabolites is the mediation of inflammation through binding of the aryl hydrocarbon receptor. Studies in mice demonstrate that indole metabolites can alleviate LPS, lipopolysaccharide-induced liver inflammation, and protect from chemically induced colitis, so highlighting the role in mediating host-inflammatory responses. So that's huge. Right, that LPS, that's what we get in our bloodstream that causes inflammation when we have a dysfunctional gut microbiome, or intestinal hyperpermeability. So we don't actually want these in the system. We want our body to be able to mediate them well. So it looks like indole helps quite a lot. Anything that's going to help on the inflammation side, with gut inflammation specifically, that's going to help our health in a massive way. So, a couple last things to finish up on here. Again, they say the striking finding in the analysis was that increasing compositional uniqueness both reflected healthy aging and predicted survival in older adults. It suggests that the gut microbiome may not only reflect, but also potentially contribute to a longer host lifespan, which is consistent with some recent non-human animal studies. So this is where it gets a bit tricky of trying to figure out, is it cause or correlation? So we know that there's correlation. I don't know how strong the evidence is yet to say it's a causative role, but there seems to be a growing amount of literature suggesting that the microbiome in many different ways, specifically what they're showing here is that uniqueness with aging may mediate aspects of healthy aging and improving our longevity over time, probably through those microbial metabolites. So it'll be interesting to see the literature grow in the space more and more to be able to give us a better idea of exactly what's happening there to enhance longevity. Because of course we have to take into consideration that healthier people may also just have healthier lifestyles, and we know things like good eating, exercising regularly, those are going to influence the microbiome as well. So chicken or the egg, we'll see when more literature comes out. So again, summarizing, They're able to show that a gradual decline in Bacteroides with age was observed only in the healthiest individuals, which is not the case in the less healthy yet still functionally independent. Because there seems to be some mix in the literature, but they're saying in other studies, they're probably looking at people who are claimed to be healthy, but are really just functionally dependent. And we know that the absence of disease isn't the same thing as being healthy. So we probably want to optimize by trying to improve that uniqueness and reduce Bacteroides. So they propose that the optimal trajectory for the adaptation of the gut microbiome to an aging human host depends on the increase of rare taxa capable of synthesizing bioactive microbial metabolites, specifically the indoles, at the expense of Bacteroides. Now, of course, this is lots of information. How much of this is actionable right now is really hard to figure out because a lot of the microbiome tests and gut tests that are available right now, they probably don't give us the amount of detail that we want, that we get from this paper, and we still don't have metabolomics available to us. But we can follow the general principles of making sure we have a healthy gut. If you do have something wrong with your gut, you're going to want to make sure to fix that as much as you can. You can contact me below for an appointment or find another functional medicine doctor or practitioner that can help you optimize your gut health. Because if you care about health, care about performance, you care about longevity, you have to make sure that gut health is doing well. All right, I think that's all I got for you today. If you like the video and the content, make sure to hit the like and subscribe and the notification bell so you don't miss out on anything new. You can check out the resources for the papers and any links or anything that I mentioned down below. All right, we'll catch you next time. See ya.